All right, lesson 5.7, systems of linear inequalities. We are going to be checking solutions, graphing solutions, and then also writing the system. So a system of inequalities looks very similar to a system of equations, but note the inequality symbols. We know what that looks like from yesterday's lesson about graphing them with either the dashed or the solid line. So if we're going to check these, we need to look at the ordered pair x and y, and we're going to substitute it into both. So is 0, greater than 2 is a question, and is 0 less than 0 minus 2, which becomes 0 less than negative 2. And the answer to both of these is no, right? This is not true for either one. So no, it is not a solution or, to this system. So one thing that you have to be careful of, make sure it has to be a solution to both. It has to satisfy both, right? So it has to make them both true in order to be able to answer this yes. All right, so go ahead and pause the video and try number 2. All right, now we're getting to graphing the system. So notice that you can see you have a dashed line because of the less than symbol. You have a solid line because of the greater than equal to symbol. So keep, working on graphing each line individually according to their solid or dashed line, and shade the part of the coordinate plane and where they overlap. So this purple part right here. So it's, if you want to use colored pencil, please do. I'll try to use some, I'll try to do the same thing um, when I'm, working and doing the examples, so that hopefully, the other thing is if you do it light enough, you can sometimes go back through and erase the part that is just solid pink and solid blue, so that only the overlapped shading shows up. So we'll show a couple different ways. All right, so here's how we do this. And again, purple, and then you want to always find some place or some point where they overlap and check it for both of them. That's how you can check it for both of them, just like we did in example 1. So I will do number 5. So again, to graph this, we have a greater than symbol, which is telling me I have a dashed line and it's horizontal at negative 2. So I can either, put down points, or I can go ahead and just draw my dashed line at the y is negative 2 horizontal line. Now, because it's a greater than symbol, I'm assuming that it's going to go up, but I could check 0, 0. So I can look at this and say, well, let's see, is it a solution? Yes, it is, because it's true. So I would graph or shade in above. Okay. Now I'm going to switch colors. So again, if you want to use colored pencils, please do. On this next one, we have the y-intercept at 0, and then it goes up 3 and over 1, likewise down 3 and back 1, and now it's a solid line. So I'll do my best to draw a solid line. And it is less than or equal to, so my instinct is that it'll go down. I could always, check a point and say, well, we already know that 0 is a solution, right? So maybe I want to check right here or right here, right? Maybe I want to check the point 0, negative 1. So I would come up here and say 0 less than or equal to 3 times negative 1. I just did that all backwards. Oh, sorry about that. Let's try this again. Negative 1 less than or equal to 3 times 0. So is negative 1 less than or equal to 0? Negative 1 is less than or equal to. So we know that this little blue dot that I drew is part of the solution. So that is another verification that it would be here. Now, look what I've done. I've just kind of like made a whole mess. So it's hard to tell that this part is actually the purple part, right? The purple part would be here and here. All this would be shaded purple, right? So what I said is, one thing you could do is go back with a pencil and kind of erase things that, I don't want to be anywhere left of the boundary line that is solid blue. In my case, I can't have anything left of the solid blue line. Likewise, I can't have anything below this dashed line. So all of this stuff below, oops, can't take out the line. It kind of sort of did. Um, so that makes it a little easier to tell that that is the solution. Again, you could, pick a point anywhere in here and check it for both of them and know that it would be true. Okay, so go ahead and pause the video and try the next one, number 6. All right. Sometimes, and I just want to point this out because we're not going to be doing any examples today, but you may come up on some of these examples. So sometimes you could have things like this where you'll have no solution. Graph the system of linear equations, you graph them, and then when you shade them, notice that no part overlaps, therefore you have no solution. All right, moving right along. So let's give this a try. I'll do the first one. I'll do it in 2 different colors again. So we'll first graph y is greater than or equal to x minus 2. So the easiest thing for me would be to go ahead and plot the y-intercept and then use, okay, the slope, make several points. Now I'm going to have a solid blue line. Okay, solid blue line. Now, is 0, 0 a solution? Is 0 greater than or equal to -2? Yes. So that means that I want to shade in this half of the plane. Okay, I've done the first line. Now I'm going to come back and grab a different color. Y is less than or equal to -x plus 2. So I have my y-intercept right here, and then I'm going to go down 1 over 1, right, several places, and then it's a dashed line. So dashed line to show that any points on the line are not part of the solution, and it's less than. So is 0 less than 2? It is. So I know that I get to shade in right here. Now I'm just going to go ahead and save myself the trouble, right? I know that I cannot shade in anything down here because that's not a part of the solution for the blue. And then I can come back and then erase anything that's marked above this red line. So you might want to do that, especially if you're just using a pencil and you haven't used 2 different colors. Then I would want to, grab a point, any point, which we already checked 0, 0, and we know that it's true for both. So we can say that we're done. So go ahead and pause the video and work out number 8. Of course, you will have to put it in slope-intercept form before you move on. So go ahead and do that. So I'm going to go ahead and work this out for you. So here we go. Let's go ahead and subtract the 2x. So we'll get 3y equal to negative. See how easy it is to substitute in these equal signs. Is less than this negative 2x plus 6. Then we're dividing by 3, which is positive. So the first equation, y is less than negative 2 over 3x plus 2. Then we'll simply add 1 to both sides for the second equation. I'll go ahead and change my color. And I'll get y is greater than or equal to negative 2x plus 1. So I'll go ahead and graph the first one and this one in blue, down 2 over 1, right, up to back 1, and it's a solid line. There we go. And it's going to be greater than. So is 0 greater than or equal to 1? It is not. So we don't shade here, we shade here. Okay, sorry about that. All right, now I'm going to go to the red one. And y is less than or equal to, so we have a positive 2 right here. and it's also a negative, so slope. So we're going to go down 2 and to the right 3, or up 2 and back 3, and it's a dashed line. And again, it's less than, and 0, 0, so 0 less than 2, no. Yeah, yes, yes, 0 is less than 2. Oh, Ms. Kleinman. So we want to shade less than, and I'm just going to keep it right in there, right? Because we want this, the blue was here, right? So technically it's all even purple in here. All right. So we can get rid of now this part of the blue. All right. All right. And so go ahead and pause the video and answer the question that I'm asking you now so that you can look at the work that you previously did. Okay, so now we are going to actually write the system. So let's take a look at this. So we have to evaluate. So it's very hard to tell, but this line is dashed. Okay, so this is definitely a dashed line. Okay, I know that this line is dashed as well, so I'm just kind of going through. You can see that this line is dashed, this line is solid, and then both of these are dashed. Okay, so just to make sure. So for number 9, I have a dashed line. We can see that this is the solution to both, which means that this horizontal line is shaded below, which would be a less than symbol. So y would be less than 3 for the first line going that way. And then the x would be less than 2. This is a 2, so x is less than 2. All right, number 10, we have this horizontal line, which again, and the double shading is right here. So this line looks like it's going below, right? Because this is overlapped here, which means this line went up. So this line had to go below. So y is less than 3. And then again, another horizontal line, it's dashed. Y is, and this time it's greater than 1. So pause the video, and I want you to give me the system of linear equations for number 11. So I want the system of linear equations for number 11. I'll go ahead and do number 12. So we have a dashed line. We have the shading between them, right? So had this one been shaded out and this been shaded out, and it would have been left a gap between them, that would be no solution. But we do have a solution, everything between these two lines. So we know that we have, you know, a y-intercept of 2, I'm sorry, 1, y-intercept of 1. Sorry, I see the number 2 and I say 2. Sorry about that. Up 1, back 1, up 1, back 1. So we have a -1 slope. So one linear equation for number 12 is that y, and it looks like then, because this part is shaded, it's going to be the less than. So is less than a negative x plus 1. All right. This y-intercept is -2, and the y, it's going to be greater than, and we have a slope of up 1, back 1. So we have y is greater than -x minus 2. So these are the two equations that represent this system. And that concludes the notes for chapter 5.